Alright, today we're just going to do a little practice on some of the more challenging types of problems in this unit. This is not an all-encompassing review, but it's just a few types of problems. So, first example. What is the equation of the tangent line to the circle x squared plus y squared equals 25 at the point 3, 4? So pause the video, find the equation of the tangent line, unpause when you're ready to check your work. Alright, so you should end up with the equation of the tangent line at the point 3, 4 is y minus 4 equals negative 3/4 times the quantity x minus 3. How do we come up with that? We take the derivative using implicit differentiation. So I get 2x plus 2y dy dx equals 0. Solve for dy dx, and I get dy dx is negative x over y. Now plug in the point 3, 4 to find the slope at that point. That is negative 3/4. So I can use the point and the slope to write my equation of my tangent line in point-slope form. You could have done this problem with explicit differentiation as well. However, that would have been more work and more difficult. Alright, next one. Find the slope at x equals 1. So you're just finding the slope of the equation y equals the quantity x squared plus 4 times the quantity square root of x cubed plus 4x, all divided by 2x plus 3. Pause the video, unpause when you're ready to check your work. Okay, so this one's a little bit of work and you have to be careful and pay attention to all of the details, but you should end up with the slope at x equals 1 is 7√5 over 10. So now let's look at how did we get that. So we have to use the quotient rule, the product rule, and the chain rule, all in this problem. So first I do the bottom, 2x plus 3 times the derivative of the top. For the derivative of the top I have to use the product rule. So I did the derivative of the first, so the derivative of x squared plus 4 is 2x, times the second, so the square root of x cubed plus 4x, plus the first, x squared plus 4, times the derivative of the second, so here I have to use the chain rule. So I bring down the exponent 1/2 times x cubed plus 4x to the negative 1/2 times the derivative of the inside, which is 3x squared plus 4. Now I go back to using the quotient rule, so it's minus the top, so I just rewrite the top, times the derivative of the bottom, which is just 2, all over the bottom squared. Now I am not going to try to simplify this at all. I'm just going to evaluate this at 1 because I'm trying to find the slope at 1. So I plug in 1. Fortunately it's a 1, so that does make things much nicer. 2 times 1 plus 3 is 5. 2 times 1 plus 4 is 2√5. 1 plus 4 is 5. 3 plus 4 is 7. 5 times 7 gives me 35. The 2 comes from the 1/2 in the denominator, and 1 plus 4 is the square root of 5, but because of the negative 1/2 it's in the denominator. Minus 1 plus 4 is 5. 5 times 2 gives me 10, and then 1 plus 4 is the square root of 5. All over the bottom squared, 2 plus 3 is 5. 5 squared is 25. Distribute the 5 here. 5 times 2√5 is 10√5. That 10√5 and this negative 10√5 will cancel. 5 times 35 is 175. Over 2√5, multiply by 1 over 25, and I end up with 7 over 2√5. I rationalize and I get 7√5 over 10. Good stuff. Next one. Alright, so given f of x equals x squared plus 2x minus 2, find the equations of the tangent lines to the point 4, negative 3, not on the function. So the point 4, negative 3 is not on the function. You're trying to find tangent lines to the function that go through that point. Pause the video, unpause when you're ready to check your work. There are 2 tangent lines. Okay, so the 2 tangent line equations to the function that go through the point 4, negative 3, not on the function, are y plus 3 equals 20 times the quantity x minus 4, and y equals negative 3. So now let's look again at how we got those. So first I find the derivative of the function. So f prime of x is 2x plus 2. Now I write a tangent line equation using the point 4, negative 3. So I know y plus 3 equals the slope, which is 2x plus 2, times the quantity x minus 4. So I simplify this and I get y equals 2x squared minus 6x minus 11. So this is a relationship between x and y of tangent lines that go through the point 4, negative 3. Now here's where I have to understand what the problem is actually asking me. I know that those tangent lines, they go through the point 4, negative 3, but they also have to share points with the original function because they're tangent to the function. They're not tangent to the point 4, negative 3. And in order to have a line, I need at least 2 points. So the other points that I know, or I don't know exactly what they are yet, but I know they have to exist, have to be on the function x squared plus 2x minus 2. So then that's where this next step comes in. I set x squared plus 2x minus 2 equal to the equation of the tangent line, or to the relationship for the tangent lines, so that I can find the x values where those do actually equal. Because the x values where those equal are going to be the x values of the points on the actual function. So this simplifies nicely, and I get 0 equals x squared minus 8x minus 9. That factors into x minus 9, x plus 1. Set each factor equal to 0, and I get x equals 9 and x equals negative 1. So these are the x values of the points on the function that where the tangent line is going to go through the point 4, negative 3. So then I find the slope at those points. So f prime of 9 is 20. So that's how I come up with one of the tangent line equations is y plus 3 equals 20 times x minus 4. And f prime of negative 1 is 0. So this is a horizontal line. So y plus 3 equals 0 times the quantity x minus 4, which is just y equals negative 3. But again, the challenging part and the really important part to understand, this shows that you really have a good idea of what you're finding with a derivative. You know, it's one thing to go through the steps and be able to solve a derivative and plug in some numbers. It's another to understand how that is relating to the actual function that you are using. Next, what makes a function differentiable at a point C? So think about what makes something differentiable. Write it down, pause the video, unpause when you're ready to check your work. Alright, so the simple way to say what makes a function differentiable at a point C is if the limit as x goes to c from the left of f of x minus f of c over x minus c equals the limit as x goes to c from the right of f of x minus f of c over x minus c. Remember, this is our alternative form of the derivative. So if these are equal, then the function is differentiable at that point C. This also means that the function is continuous at C, that the limit exists at C, all of those things, but this is the simplest way to state that it's differentiable. Alright, last one. Find k such that y equals negative 2x minus 5 is tangent to f of x equals kx squared plus 1. Pause the video, unpause when you're ready to check your work. Okay, so here we should get k equals 1/6. So now, how did we get that? So, first we find the derivative of the function. So f prime of x is 2kx. Now I set the derivative equal to negative 2, because negative 2 is the slope of the tangent line, and that's what the derivative represents, the slope of the tangent line. So I want to solve this equation for k. So I have a relationship between k and x. I know negative 1 over x is k. Now I set the equation of the tangent line, negative 2x minus 5, equal to the equation of the function, kx squared plus 1. The reason why I'm doing this is the same reason that I did this 2 examples ago, where I know the function and the tangent line have to share a point because they intersect at one point. So I can find that x value setting these equal to each other. When I do this, I also substitute in for k. So I have negative 2x minus 5 equals kx squared plus 1, but k is negative 1 over x, so negative 2x minus 5 equals negative 1 over x times x squared, and then plus 1. And now when I simplify, I end up with x equals negative 6. So if x equals negative 6, that is the x value of the point where the line y equals negative 2x minus 5 is tangent to the function f of x equals kx squared plus 1, when k is 1/6. So I can plug x equals -6 back into this relationship here, and I get k is positive 1/6. So in general, you really want to make sure you know the product rule, the quotient rule, the chain rule, the power rule, obviously. All of those make derivatives much simpler and possible in some cases. And then we want to really understand what a derivative represents. It's instantaneous rate of change, which in terms of a function is the slope of the tangent line at a point. In terms of position, that means velocity. In terms of velocity, that means acceleration, but it's always at that instant. Understand the difference between explicit and implicit differentiation. Explicit means that it is a function in terms of the variable that you're trying to differentiate with, whereas implicit means that it is not a function in terms of that variable, so we have to use the chain rule for each term that is not that variable. In most cases, that's x when I'm referring to that variable. Okay, that's it.